I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Jam, what's up? How are you doing?
Dude, I'm doing great. I'm tired, but I'm doing great. I'm surviving.
That's good. That's really good.
Yeah. How about you?
Oh, my family's watching a hockey game without me right now, so I'm a little bummed about that. But otherwise, things are going good.
Dang, that's a bummer. Although, it's weird how some situations, the opposite would be true for somebody else. It's like,
like if your family was watching a hockey game without you.
My family was watching hockey without me. I was totally off the hook. Great day.
That's okay. I mean, it's a fun thing I do with my dad and my brother. So, and it's a pivotal game. So
yeah, fair enough.
It's okay. I'm gonna survive. There's more to life than hockey. Like hanging out with you and podcasting about chemistry.
Absolutely. And figuring out what makes life happen, sort of.
Yeah, that's true. That makes this a lot more significant if you think about it.
Anytime you need me to word it in a very overly emphasized, significant way, I can totally do that.
Okay.
Especially when it comes to comparing sports to something like science.
Oh, yeah, 100%. Okay, well, this week we're definitely going to talk about something that's everywhere. And it's part of, the fabric of our everyday lives.
Okay.
Okay, so I was at my sister's house a few weeks ago.
Mm-hmm.
And my brother-in-law came out on the porch and he said, Melissa, how do I get rid of CA glue on my hand?
CA glue.
I said, what's CA glue? And he said, it's super glue. It's cyanoacrylate glue. And how do I get rid of it on my hand, chemist? And then listener Mason K said he wanted to know about glues. And then Marlene C said that now that she listens to our podcast, she brags to people about cast irons and polymers and sounds really smart, even though she doesn't really even know what they are.
I mean, she definitely knows more than her friends do.
That's true. That's what I think. But all those things came together in my mind, and we're going to do an episode all about polymers and all about superglue.
So that is the same episode that is happening now? Or are they
This is
different
all
episodes?
happening right now. And so it's dedicated to JD and Marlene and Mason. Thanks, guys.
Nice. Sweet. Very cool.
Okay.
You guys really came together on this one.
Yeah, you did. You really did. So let's talk a little about polymers. We've talked about them before.
Mm-hmm.
They are a substance that's composed of molecules that are big molecules. They're called macromolecules. And they have long sequences of repeating units. So those individual units are called monomers.
Okay.
You made up a description for them. Do you remember what it was?
Monomer?
For polymers overall.
Is it this is the thing where I said it's a large molecule that's made up of small molecules?
That's exactly right.
Okay, good.
So the small molecules are the repeating units. They're also known as monomers, and they make up the large molecule, and that's the polymer.
Monomer,
polymer. That's right.
Got it. Okay, sweet.
I don't know what mer is, but mono and poly. That's right.
Is it mer like the C in French?
Yeah, I bet it's a one C or many C's. I'm just kidding. Okay, so, and those repeating units can be the same over and over. They can be A, like the same little molecule over and over. Or it can be a series of molecules. ABC, ABC, ABC.
Okay.
Something like that. Okay. So polymers are everywhere.
Okay.
They're in food science. They're the Maillard reaction. It makes a polymer.
Oh, yeah.
They're all over natural science. Our DNA is a polymer.
Mm-hmm.
And we make and produce polymers all the time. Plastic is a polymer. Nylon is a polymer. There's lots of polymers.
Mm-hmm.
Polymers. There's lots of polymers all over the world. And I actually took a class on polymers in undergrad, and it was really fun. It was one of my favorite chemistry classes in my undergrad. I almost went into polymer research.
Wow. Dang.
So I pulled out that textbook about polymers, and I want to read you an excerpt from the beginning of the book.
Okay. Sweet.
Okay. It says, from the earliest times, man has exploited naturally occurring polymers as materials for providing clothing, decoration, shelter, tools, weapons, writing materials, and other requirements. However, the origins of today's polymer industry is commonly accepted as being in the 19th century, when important discoveries were made concerning the modifications of certain natural polymers. But I just liked that it goes all the way back to the earliest times that we've been using all these naturally occurring polymers. But then in the 19th century, we made some changes to some natural polymers, and that began the modern science of polymer chemistry.
Dang, interesting.
Tracking with me?
Yeah, I am. It kind of started like a story, you know?
Yeah, it is kind of like a story. It's a story of how nature has made these really useful large molecules that make substances that are really useful for us to use. And then we began the journey as humans of discovering how to recreate that and bend them to our will, which is a lot of what we do in synthetic chemistry, is bending things to our will.
And it's kind of been the story of humans in a lot of ways. It's like we try to figure something out so we can bend it to our will, like just period, for good, for better or for worse, you know?
Yeah. Better for worse. Bending things to our will. Okay. So what does this have to do with superglue? So superglue is basically a tube full of monomers, or molecules, as Jim likes to call them. And they come out of the tube and they react with, there's usually a thin layer of moisture that pretty much coats everything. In science, if we're trying to get rid of it, we bake glassware in the oven and stuff so that all of that has to evaporate off.
Weird.
So these monomers or molecules come out of our superglue tube and they hit that moisture and they hit moisture on the other layer and of whatever you're trying to glue together. Part A and part B gluing together. There's moisture on each part, and they use that moisture to form a polymer. And that polymer has those strong bonds that bind the two pieces together.
Interesting. So it's just part of a polymer looking for its other part so that it can become a polymer.
It's just a polymer. It's basically
Incomplete.
molecules becoming a large molecule.
Yeah.
And those bonds are really strong.
Yeah. It's kind of like how we now have all these pre-mixed, things you can buy at the store for baking or whatever, and all it needs is just throw an egg in here. We have everything else mixed the right way, but just throw an egg. It's like we're just missing one thing.
So it's just missing. There's something in the water that it's missing that allows the polymer to form.
Nice. Dang, that's crazy.
Okay, so we're going to talk about it a little bit more, though.
I don't know if I can handle that.
You can handle it. I know you can.
Okay.
You know why I know you can?
Why?
Because every time you use super glue, you are being a polymer chemist.
Whoa.
I mean, not really, but maybe polymer chemists will be mad at me for that. But you're doing a polymer reaction. You're creating a polymer. You're synthesizing a polymer every time you use super glue.
Yeah.
Okay. So when we synthesize polymers, a good way to think about them is a chain reaction. And I had a hard time coming up with a good analogy for this, but you can maybe help me with that, Jim. You're good at that. So it happens in 3 steps. There's an initiation step, a propagation step, and a termination step.
Okay.
So initiation step starts the reaction. It's the initiator.
Okay.
And then the propagation step keeps the reaction going. It's just going. The chain reaction part.
Okay.
And then the chain reaction hits something that ends it. That's a termination step.
Okay.
Okay. So that's how polymers are made. That's how molecules become a molecule. That's how they form the big molecule.
Okay.
Okay. So I was trying to think, is that maybe like fire or maybe like dominoes falling? I don't know.
Dominoes is what I thought of too.
Dominoes is what you thought of? I wasn't sure if it was good.
I was thinking about dominoes. That's what I was going to try to. I mean, I don't really fully understand things until I try to do an analogy that may or may not work, but that's what I was going to go with.
Okay. Well, be holding on to that and see if this lines up with what you're thinking for dominoes. Okay. So in the case of superglue, there's a lot of different types of these reactions. So we're going to hone in on when you're making cyanoacrylate superglue. Okay. So the initiator in that is water. So when the tube full of monomers basically hits the water, there's some negatively charged molecules in the water, and those start the reaction.
Okay.
So I don't know if you remember, but negatively charged molecules, we're going all the way back to the beginning.
Mm-hmm.
Electrons are negatively charged.
Right.
The negatively charged molecules have extra electrons.
Okay. Because a lot of molecules are at balance, right? Like they have electrons and they have protons, and they're just that neutral kind of thing, right?
Right. They're neutral. They have all the numbers of electrons that they want in the forms of bonds around them. Well, atoms aren't bonded, but molecules have neutral atoms that are bonded.
Okay.
Atoms are the individual carbon, hydrogen, whatever, and a molecule is those bonded together. Okay. So you've got this negatively charged molecule. It's a hydroxide ion. That doesn't mean much for probably very many people, but in case it does, that negatively charged molecule is going to come to the monomer, this molecule, and try to form a bond. Bonds are made up of electrons shared between two atoms.
Is this, what's the ion again?
Hydroxide, but you can just think of it as a negatively charged something.
And this just occurs in water a lot?
Yeah, there's trace amounts of hydroxide in water. I mean, I think, I'm not super clear for sure, but I would guess it's because there's a lot of salt in water, and water is made up of oxygen, hydrogen, and another hydrogen. Hydroxide is an oxygen and hydrogen missing that extra hydrogen. So it's missing a proton, so it's OH minus. So it's not surprising to me that there's trace amounts of these negatively charged molecules in water.
Okay.
So that negatively charged molecule or ion will come and attack to try to form a bond with one of the monomers or molecules. So it tries to form a bond with this monomer, but the monomer is neutral. It doesn't have a charge. So when your negatively charged atom comes and tries to form a bond, now the monomer is negatively charged.
Oh.
Because now it has too many electrons.
Got it.
So then it wants to go and form a bond with something else, but it's surrounded by monomers, so it forms another bond with another monomer. And now that monomer has too many electrons around it and is negatively charged. So then it goes and forms another bond on the other side. So they're just linking together one after another. It almost is like hot potato, but forming a bond each time. So
yeah.
Or maybe like that snake game where you start with one person and you grab another and then you grab another and it just gets longer and longer.
Yeah.
So it just passes along that negative charge over and over, and that's the propagation step.
Okay.
So the hydroxide ion, the negatively charged molecule coming at the monomer, that's the initiation step. And then passing that negative charge along, forming new bond after new bond after new bond, that is the propagation step.
Okay. Got it.
Okay. So there's two options to end that. One option. It runs out of new monomers to react with.
Right.
And that's called a living polymer. If it found a new monomer, it'd keep reacting, but if it's run out, it just stops.
Okay.
The other option is a termination step. And a termination step is when this negatively charged thing finds a positively charged thing.
Oh.
And then there's no more negative charge to pass around, and then boom, it stops.
Got it.
Okay. That is how a polymer is formed. So when you put super glue on anything and it starts to harden, including your fingers, what happens is the moisture that has trace amounts of hydroxide ion in it hits that polymer. It initiates the negative charge being passed from monomer to monomer to monomer, forming bonds as it goes along. And then you get a very long molecule that has different properties than the individual monomers. It's hard and it's bound very solidly to your finger or whatever.
Yeah. Dang. Interesting.
And now you know how to synthesize a polymer, and you know how you have synthesized a polymer before.
That's crazy. I didn't know I was doing such complex chemistry when I was using super glue.
But you are. And the chemists have luckily made it very easy for you to do that.
What's funny too is that I feel like gluing yourself to yourself or gluing yourself to something is typically a sign of, stupidity to some degree, even though it's relatable to all of us. But what we didn't really know is that actually it's a sign of brilliance. That person just created a polymer.
That's exactly right.
So that person's actually a genius.
They didn't really create a polymer. That's sounds like they made a new one. They just synthesized a polymer.
Right.
I guess you could say create, but.
They initiated, there was not a polymer, and then they did something, and then there was.
That's exactly right.
Wow.
Just to all the polymer chemists out there, I want you to know that your job is really hard and it's not this simple for you to make new polymers. And I'm very impressed with you, but it's pretty cool that everyday people are using polymer chemistry in everyday life.
Mm-hmm. Yeah, it's definitely cool no matter what. The whole thing's cool, I think.
Okay, so Jam, that's it. That's my lesson for you today. Can you give it back to me? And can you use a better analogy than I could think of? Because I was struggling.
I can give it back to you. Let me see if I can think of an analogy.
Okay.
I think I have one, but it's kind of, we could just try it if we want.
Okay, I'm ready. And also, for the listeners at home, I'm going to post a visual aid of this, and I'm going to do it both with molecules and also just with circles or something to represent the monomer so that you can visualize how this happens.
Okay, so you've got a tube of these monomers, which are kind of like, if you think about it, just kind of like people who are neutral at the moment. They're just right at the middle. They're not in a great mood. They're not in a bad mood. They're just normal.
Normal.
And then you release these people out of this tube, and the first person that leaves the tube, he encounters a person who's in a bad mood. And you know what happens a lot of times when you encounter somebody who's in a bad mood? It's kind of contagious, not in the usual, way, but in a way of kind of being like, oh man, yeah, things aren't all great. Or yeah, actually I'm kind of annoyed by whatever too. Or who knows what. Anything under the sun. So you turn around and you're in a bad mood now. And all the neutral people behind you start to rub off your bad mood on them too. And before you know it, you've got this whole group of people in a bad mood, which is a force of nature right there.
Force to be reckoned with.
And you get this whole group of people who are all in a bad mood, and pretend that maybe it's even about the same thing. For instance, I've noticed that a good amount of people have negative feelings about Arby's that I believe they've gotten from somebody else. And now there's this whole force of people who all, by one person's bad mood about Arby's, all don't like Arby's now.
That's what I think about organic chemistry too. I think people cause other people to be afraid of it, which then causes other people to be afraid of it. That's my research.
There we go. Exactly. And maybe
is a good example.
Somebody had a reason to not like their Arby's experience that time, or maybe somebody didn't have the best or an introduction to chemistry that first time. However, it's, as people, we do kind of sometimes get thinking the same way about things because of how other people think. Just like how a negative charge from this ion can just catch and get this whole group of monomers to become one whole polymer. And then it's hard to change, right? Everybody thinks, for a couple years now, I've been trying to change people's minds about Arby's, to be honest with you guys. All right. I'm not trying to say it's the best, but I'm just trying to get people to get back to that monomer, back to that neutral a little bit about Arby's.
Yeah.
And it's hard. They have become a polymer in their thinking.
Well,
thanks for coming to my TED Talk.
I think that's good. I want to make sure people know too that I think that was a good example because they're now bound together. This forms new strong bonds that are really holding on tight, which is why glue sticks things together, holds things together. You feel some of those bonds forming as it gets harder and harder, as stickier and stickier between your two fingers, for example, you know? You can feel the polymer starting and the bond starting to take place. They're now holding on tighter and tighter.
Yeah.
And so I think that that's good because it shows that it's now a new force. They've joined together in their negativity. That's a good way to put it. So,
and I was thinking that one reason I picked that analogy, I was thinking too that if you encounter somebody who's in a great mood, sometimes it can stop the chain from continuing, like the termination phase. Not every time at all, but there's definitely times where that's the case, where you could stop this contagious bad moodness by encountering somebody who's like, you know, I just realized it's such a beautiful day outside today. And I had, it wasn't that like mind blowing, but I had a pretty solid sandwich at Arby's today. And I'm satisfied. I'm not hungry anymore. And
this episode brought to you by Jam and Arby's.
And this is that kind of thing though that can happen. And if it happens right, it can actually change some people's mood or whatever for the better.
That is a great way to think about it. I do want to emphasize, I think your analogy is great. The new molecule is neutral, just so you know.
Right.
But you had a good analogy of this negativity spreading and binding people together. And I can also draw a picture of it. But I think that is a good way to think about it. And
neutral in like the charge sense, right? You mean? Okay, got it.
Yes. It's neutrally charged. Yes, it's no longer negative or positive molecule. If there's a living polymer, it can have a negative charge on the very end, but it's that.
I have a question.
Yes.
So I put a big old hunk of super glue on my finger. And then I stick it to my other finger. Is that whole entire hunk of super glue actually one molecule?
So I don't think so. I'm not incredibly clear on that. It's possible that this is a little complicated into polymer chemistry, but it's possible that you have multiple initiation sites. So there are multiple.
Oh, got it. But they're all kind of tangled up and stuff.
I think you'd have to talk to a polymer chemist that might have a better understanding of the molecular level of polymers in substances like that.
I was thinking like, what if it was kind of cool that it was all one, and then it's like, I'm holding a molecule. I can see it. I can touch it. It's just like one just big, complicated molecule.
One of the books I was reading was very clear to say that the polymer is the substance, and the substance consists of the molecules, the big molecules. So the polymer isn't the molecule. It said that people often use macromolecules and polymer. Macromolecule is big molecule. Macromolecule and polymer interchangeably, but they're not. So
got it.
That's what my polymer textbook said. So I wonder, I think polymer chemists might get in a tizzy about that. I don't think that's probably correct. It could be, but I don't think it probably is.
And rightly so. They are the people to get in the tizzies about these things. It's up to them.
Yeah. That's their job to know all about it.
Yeah. Well, I just thought it'd be cool, but I'm glad I asked that so that I don't now misunderstand and go tell people that I'm holding a big old molecule.
I'm glad you did too, but you can say this substance is made up of a bunch of big old molecules, maybe.
Yeah.
Or consists of big molecules. Well, that's good. I like the dominoes one too, because I think that demonstrates initiation, everything falling down.
Yeah.
Is the propagation, one leads to the other, leads to the other, leads to the other, and then the termination of when you finally get to a gap in the dominoes, and so it can't keep falling.
Yeah,
but there's not a good analogy. It's not great because it's not like it's a new force necessarily. You know, it's not like a new thing has been created. It's not a new substance, really. I mean, it kind of is, but
yeah.
So that's another way you can think of it. But that's the general idea: is the initiation, propagation, termination, and those molecules, those individual molecules, get bound together in the propagation step.
Dang, yeah. Interesting.
Very, that's very a good one.
Yeah.
You made quick work of that. You wrapped it up with a bow on top and even tied in Arby's. Good job.
That's a complete package right there.
That is complete. Now I want some curly fries. So
I think why not?
We should all get some curly fries. We should all go and get some curly fries. Everyone who's listening to this right now, go get some curly fries.
I think you deserve it, honestly.
I think you're right, Jam. Okay.
Just saying.
Well, other than curly fries, is there something that has made you happy this week?
I don't really have a one thing that has made me happy this week, but I'll say I've had a much busier work week this week than I have in a while. And we're recording this on a Friday, and the week is over. And
late on a Friday in the middle of a Game 7 hockey game.
Right.
I just got news that the Dallas Stars won in an incredible overtime move in the middle of our recording session.
Wow, nice. There you go. There's your happy thing.
I like to think that us talking about science really spurred them on.
I hope so. Yeah, seriously.
Anyway, yes, we're working late into Friday night.
Yes, and the week is over. And
the week is over.
I feel like that bit of tired where you are like, man, I worked hard, and that's why I'm tired. It's like kind of a good feeling.
Yeah, satisfying.
And I have had multiple weeks where I don't have a totally full work schedule. I might still be tired and stuff, but I've had times where it's like, definitely could have had more work or whatever. And I definitely don't want to feel like I'm all the way maximum full all the time. But I do feel like this week was like a little bit refreshing how full it was in terms of work. But I'm also glad that it is now over. And I feel a little bit like, okay, I can put up my feet and chill and feel like I earned it.
You enjoy the satisfaction of a job well done.
Yep.
Nice. Congratulations.
Yep. So that was my deal.
Mine is actually pretty similar. I am also happy that the Dallas Stars won because that means the season is going to keep going. So that's one of my happy things.
And we'll see you guys next week.
No. My other happy thing is that I'm currently recording from my new desk in the new lab that I'm sitting in for hopefully the rest of grad school.
Nice.
So shout out to Drs. Weber and Atkinson who worked to get me this place to sit, and I'm really excited. I'm really happy. I have a home. There's a small room that I can use for podcasting even when more students join me in the lab space. I'm really happy.
Nice. I think you teased that this was in the works, but it was not done yet.
I may have, right. Yeah,
but
I think
now
I
it's
did.
Here.
But it's here. Things had started to shape up, and now it's here. And this is our first ever podcast recorded from my new desk.
Nice. And I got a little Marco Polo tour of it just a second ago, which is cool. So,
and I'll post pictures of that because I'm very excited about it. I also have the Dallas Stars up here, so some bobbleheads that I got for free cheering me on.
Nice.
Great. Well, this has been a fun episode.
Absolutely. Yeah, it was really fun.
Thanks, Jam, for fitting us into your super busy schedule, your full work week.
Oh, yeah.
And thanks. You're so high priority, high VIP.
No, it was great that you were able to get some time on with my secretary. You guys were able to find a good window. So, yeah.
Yeah, thanks. Thanks, Jam Secretary Diane. And thanks to all of you listeners who came and listened and learned about polymers. We couldn't do it without you. And I absolutely love that we get to spend our Friday nights doing something this awesome.
Absolutely. And thanks, Melissa, for teaching us and for diving into these topics that, especially in this case, was like suggested by 3 different people in kind of 3 different ways. So if you have ideas, things that you're curious about, things in your everyday life that you're like, I wonder what the chemistry is like behind this, then that's why this podcast exists. So just reach out to us, give us your ideas and your thoughts. Twitter, Facebook, Instagram, Gmail, at Chem for Your Life to share your thoughts and ideas with us. If you'd like to help us keep the show going and contribute to cover the cost of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you are not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. References for this episode can be found in our show notes or on our website. J.M. Robinson is our producer, and we'd like to give a special thanks to A. Collini and In Newell, who reviewed this episode.